All right, let's go. Number 10. The side effect. In 1992, theoretical physicist Lee Smolin, now a founding member of the Perimeter Institute for Theoretical Physics in Waterloo, Ontario, published a hypothesis in the journal Classical and Quantum Gravity that would later become the foundation of his 1997 book, The Life of the Cosmos. He proposed that every time a black hole forms, the singularity at its core doesn't crush to infinite density. It bounces, and on the other side, a new universe begins expanding, inheriting the physical constants of the parent, but with small, random mutations. The unsettling part isn't that universes reproduce, it's what that makes us. Universes that produce more black holes spawn more offspring. Over countless generations, this creates Darwinian natural selection on a cosmic scale, a competition among realities, where the winners are the ones most efficient at collapsing matter into gravitational points of no return. The conditions that maximize black hole production, long-lived stars, carbon, oxygen, complex chemistry, happen to be the same conditions that permit biology. The math says we exist not because the universe was designed for life, but because life is a byproduct of a process optimizing for gravitational collapse. You are not the point of the universe. Black holes are. You are a side effect of a cosmos learning to eat itself. Number 9. The mirror. In December 2018, physicists Latham Boyle and Neil Turok of the Perimeter Institute, along with Kieran Finn, published a paper in Physical Review Letters proposing a model of cosmology built on one of the deepest principles in all of physics, CPT symmetry. The rule states that any physical process remains identical if you simultaneously replace all particles with antiparticles, mirror reflect space, and reverse time. What makes this quietly disturbing is what CPT symmetry demands. Boyle and Turok propose the Big Bang is not the beginning of time, it is a mirror point. On the other side, extending backward from the same origin, is a second universe, made entirely of antimatter, with reversed spatial parity, and time flowing in the opposite direction. The pair emerges from nothing. No inflation, no prior cause, no mechanism except the deepest symmetry nature possesses. In a companion paper published in the Annals of Physics in 2022, the team showed this model elegantly produces dark matter, a species of right-handed neutrino, stabilized by CPT symmetry itself, radiated from the bang the way Hawking radiation escapes a black hole. There is a universe on the other side of the Big Bang running backward through time. It is made of antimatter, and by the deepest symmetry in physics, it must exist. Number 8. The Bruise. In 2008, theoretical physicist Laura Mersini-Houghton of the University of North Carolina at Chapel Hill, working with Richard Holman of Carnegie Mellon University, published a framework in Physical Review D that offered an explanation for one of the most stubborn anomalies in modern cosmology, the CMB cold spot. First detected in WMAP satellite data around 2004 and confirmed by the Planck satellite in 2013, is a region in the constellation Eridanus approximately 5 degrees across and 70 microkelvin colder than the cosmic microwave background average. The implication nobody in cosmology wants to say out loud is what left the mark. In 2015, astronomer Istvan Sapudi of the University of Hawaii detected the Eridanus supervoid aligned with the cold spot at greater than 5 sigma significance. But the void can explain only 10 to 20% of the temperature depression. The rest has no standard explanation. Mersini-Houghton's framework begins in the string theory landscape. Before inflation separated nascent universes, they existed in a state of quantum entanglement. The cold spot is a gravitational scar, a density contrast imprinted on the oldest light in existence by the pull of a neighboring reality pressed against ours before inflation tore them apart. There is a cold spot in the oldest light in the universe. It shouldn't be there. And the best explanation anyone has is that something on the other side pushed. Number 7. The lottery. In 2000, physicists Raphael Bousso of UC Berkeley and Joseph Polchinski of the Kavli Institute for Theoretical Physics at UC Santa Barbara published a paper in the Journal of High Energy Physics demonstrating that string theory's 6 extra spatial dimensions could be compactified in an almost inconceivable number of distinct ways. In 2003, Leonard Susskind, the Felix Bloch professor of theoretical physics at Stanford, gave that space of possibilities a name: the landscape. The truly horrifying aspect isn't the number, it's what it does to the idea that anything about our universe is special. The landscape contains approximately 10 to the 500th power distinct vacuum configurations. Each yields a universe with different physical laws, different particle masses, different force strengths, different constants. Most produce realities where atoms cannot form, chemistry is impossible, and nothing resembling structure could exist. The electron mass, the strength of gravity, the speed of light, none of them are fundamental. They are environmental accidents. In 1987, Steven Weinberg showed that even the cosmological constant, a value fine-tuned to 120 decimal places, can be explained without design if the number of possible vacua is large enough. 10 to the 500th power is large enough. Your universe is one configuration out of 10 to the 500th power. There is no reason it had to be this one. You won a lottery that nobody entered on purpose. Number 6. The foam. In 1983, physicist Alexander Vilenkin of Tufts University published a paper in Physical Review D demonstrating that under certain conditions, cosmic inflation does not end everywhere at once. In 1986, Andre Linde of Stanford published a complementary result in Physics Letters B. Together, their work established the framework now called eternal inflation, and that's where the silence gets loud. Quantum fluctuations in the inflaton field occasionally push energy upward rather than letting it decay. Those regions inflate faster, growing in volume exponentially, while local pockets, like the one that became our observable universe, exit inflation and cool into big bangs. Our universe was a local bubble nucleation event in an eternally inflating void, one of infinitely many. The process never stops. New universes are forming right now, at a rate so fast the inflating volume increases by a factor of roughly e to the 10 to the 37th power every second. And here is the deepest problem. In an infinite multiverse, everything that can happen does happen infinitely many times. This is the measure problem, formalized by Busso, Garriga, Vilenkin, and others. The mathematical inability to assign meaningful probabilities when everything occurs without limit. Our universe is one bubble in an infinite foam. New bubbles are forming right now. Most of them are empty, and the foam never stops. Number 5. The copies. In May 2003, physicist Max Tegmark of MIT published an article in Scientific American with the full academic treatment appearing on ARCS IV as Astro-PH/0302131, classifying 4 levels of multiverse. The first level requires only one assumption, that space is infinite. Here's where it becomes personal. In an infinite universe, the observable universe is a finite sphere, roughly 42 billion light-years in radius. A Hubble volume contains approximately 10 to the 80th protons. The number of possible quantum states in a region that size is approximately 10 to the 10 to the 115th power. In infinite space, every possible configuration of particles must eventually repeat. Tegmark calculated the distance to your nearest identical copy, a person with your exact atomic arrangement, your exact memories, reading this exact sentence at this exact moment, at approximately 10 to the 10 to the 29th meters. That number is so large that writing it out in standard notation would require more digits than there are atoms in the observable universe. And beyond that copy, infinite variations, versions of you who made every possible different choice, every triumph, every catastrophe, every version who made the worst decision at every juncture. There is an exact copy of you right now, living your exact life, at a distance so large the number itself is incomprehensible, and beyond it, infinite copies making every choice you didn't. Number 4. The wall. In 1977, theoretical physicist Sidney Coleman of Harvard published a landmark paper in Physical Review D describing how a quantum field could tunnel from a higher energy state to a lower one, a process he called false vacuum decay. In 1980, Coleman and Frank DeLucia extended the work to include gravity. The mechanism was theoretical until the Large Hadron Collider gave physicists a number they didn't want. What nobody expected was that the LHC would put us on the wrong side of a line. In 2012, the ATLAS and CMS experiments measured the Higgs boson mass at approximately 125.1 giga-electronvolts. Absolute vacuum stability requires a Higgs mass above roughly 129.6 giga-electronvolts. We are 4.5 giga-electronvolts below the threshold. Degrassi and colleagues, working across CERN, the University of Rome, and the University of Pisa, reported in the Journal of High Energy Physics that vacuum stability is excluded at 98% confidence for our measured Higgs mass. If a bubble of true vacuum nucleates through quantum tunneling, it expands at the speed of light. It dismantles atoms. It rewrites the laws of chemistry. No warning signal can outrun it. It arrives at the same speed as the light that could tell you it's coming. The standard model says our vacuum is not the lowest energy state. A bubble of true vacuum could be expanding toward you right now at the speed of light. You would never see it coming. You would simply stop. Number 3. The off switch. In April 2003, philosopher Nick Bostrom of the University of Oxford published a paper in the Philosophical Quarterly that has since become one of the most cited arguments in the philosophy of science. His trilemma is precise. Either virtually all civilizations destroy themselves before achieving the computational power to simulate conscious minds, or all technologically mature civilizations universally choose not to run such simulations, or we are almost certainly living in one. The scenario that should unsettle you most isn't the simulation itself. It's what Preston Green proved about looking for it. Green, an associate professor at Nanyang Technological University in Singapore, published a paper in the journal Erkenntnis in 2020, arguing that if a simulation's inhabitants discover they're simulated, their behavior changes. The simulation no longer serves its original research purpose, and the operators, who are, as Bostrom notes, effectively omnipotent and omniscient relative to the simulation's inhabitants, may simply shut it down. This isn't a plot from science fiction. It's a logical consequence of Bostrom's own framework. If the simulation exists to study how civilizations develop under specific conditions, the moment those conditions are compromised, the experiment is over. Testing whether you live in a simulation could be an extinction-level event, not because you'd learn the truth, but because learning the truth might end the experiment. If this is a simulation, there is an off switch, and the worst thing you could do is give someone a reason to use it. Number 2. The fluctuation. In 2004, physicists Andreas Albrecht and Lorenzo Sorbo of UC Davis published a paper in Physical Review D that gave a name to a problem that had been lurking in cosmology for over a century: the Boltzmann brain. The concept traces back to Ludwig Boltzmann himself in 1895, but it was formalized for modern cosmology by Lisa Dyson, Matthew Klebin, and Leonard Susskind of Stanford in a 2002 paper in the Journal of High Energy Physics titled Disturbing Implications of a Cosmological Constant. Every other entry on this list assumes you are real. This one doesn't. In a universe dominated by dark energy, empty space has a finite temperature, the Gibbons-Hawking temperature, approximately 10 to the negative 33rd electron volts. Given infinite time at that temperature, random thermal fluctuations will produce every possible configuration of matter, including conscious brains, complete with false memories of childhoods, friendships, and entire lives that never happened. The timescale is staggering, 10 to the 10 to the 50th years at minimum, but in eternal de Sitter space, time doesn't run out. Over eternity, randomly fluctuated observers outnumber real biological observers by an incomprehensible margin. Sean Carroll of Caltech addressed this directly in his 2017 paper, Why Boltzmann Brains Are Bad, arguing that any cosmological model predicting more Boltzmann brains than real observers must be rejected, because it undermines the very reasoning used to support it. Your memories of yesterday, your childhood, the sensation of reading this sentence, all of it could be a thermal fluctuation in empty space that will dissolve in a fraction of a second. The math doesn't say this is unlikely. The math says this is almost certain. Number 1. The trap. In July 1957, a 26-year-old doctoral student at Princeton named Hugh Everett III, working under the supervision of John Archibald Wheeler, published a paper in Reviews of Modern Physics that proposed the most radical reinterpretation of quantum mechanics ever put to paper. He argued that the wave function never collapses. Every quantum measurement causes the universe to branch. All outcomes occur. Every one. In November 1998, physicist Max Tegmark, then at the Institute for Advanced Study in Princeton, published a thought experiment in the journal Fortschritte der Physik that took Everett's framework to its logical endpoint. Place a person before a quantum-triggered lethal device. From a third-person view, there is a 50% chance of death with each trial. But from the first-person perspective, the experimenter only ever finds themselves in the branch where they survive. Death eliminates the branches where observation could continue. Extend this to its conclusion, and the implication is this: you subjectively never die. Every other entry on this list is something that could happen to the universe. This one is something that is already happening to you. You keep experiencing the branches where you survive, aging, degrading, losing everything, but never quite reaching the end. In March 2004, the Australasian Journal of Philosophy published a posthumous paper by David Lewis, one of the most respected analytic philosophers of the 20th century, in which he described the consequence with a precision that has never been surpassed. You should expect to lose your loved ones, your eyes and limbs, your mental powers, and your health. Eternal life on such terms amounts to a life of eternal torment. If the many worlds interpretation is correct, you are immortal, not in the way anyone would want. You will watch everyone you love die in branch after branch while the math keeps finding one more version of you that survives. You cannot opt out. You cannot reach the branches where you don't exist. You are already in the trap. And the math, the same math that started this list, says it never opens. If you want to see more videos like this, click the video on screen now and make sure to subscribe.